Hello and welcome back to Machine Learning. I'm Jivita Christie, and in this video, we are going to talk about um, what factors can affect the quality of your data, as well as what you can do to improve the quality of your data. So let's begin. First, we'll talk about factors that can affect the quality of your data. So the first factor is getting an incorrect sample set selection. So what happens here is that the data may not reflect normal or regular quality due to incorrect selection of sample set. And an example for that is if you're having some sales transaction from a festive period, okay, that means you have some festival like Christmas or Diwali going on, and if you have some data from that time period and you are using that data to predict future sales, then that's going to be a wrong prediction because in a festival time or Diwali time, naturally the sales are higher. You cannot use that data to predict future sales. Okay, so prediction will be very, very far apart from whatever is the actual scenario, and you will definitely get a wrong prediction. Similarly, if you're trying to predict poll results using some training data that does not comprise a right mix of voters from different segments, like you did not consider voters with different age, sex, ethnic diversities, etc., then the prediction again can fail. Okay, because it's very important that when you take a sample data, it has to be completely unbiased and has to be completely random, and it should include all categories. So you have to include people of all ages, genders, ethnic diversities, consider all states and everything. Only then you can do a proper prediction. Okay. You can also have a problem with incorrect sample size. For example, you might go ahead and collect a very small sample size. Okay, so the sample size is so small it um, does not give you a proper prediction. The second type of factor that can affect your data quality is errors in data collection. So sometimes when we collect data, we can have outliers. We know that outliers are values that are far away from all other values. So they are not following the general pattern of your data, but they're following something else. And that's why they are very rare values um, that if you create a scatter plot will be far away from all other values. So outliers have their effect or impact on your training, and that's why they are bad. And you also have missing values. So sometimes um, you have values which are just not there. So some column is there, but then some of the rows, those some values are missing. Okay, so that is error in data collection. Another kind of factor is that in many cases, person or group of persons are responsible for collection of data. And in this manual process, there is a possibility that while entering the data, they enter wrong data. For example, instead of 20.67, someone is entering 206.7 or 2.067. Okay. And if you do that, it makes a huge difference, right? So some of the elements might be abnormally high. They may have abnormally low or high values, and they can just become outliers just like that because someone entered wrong data. It can also happen that some data is not recorded at all. For example, if you took a survey to collect data, it is quite possible that the survey responders do not respond to a certain question, right? Because it's a survey, they don't have to respond to everything. So maybe while taking the survey, they skip some of the questions. So that means that responder's record is going to be missing. So these are all the factors that can affect your data quality. And of course, we cannot do something about every factor, but we can do something about some of these factors. Like we can handle outliers, we can handle missing values, we can do something about all these. So let's now talk about data remediation. So data remediation is all about how your data has problems. We know that it has problems, but now we are talking about how we can solve some of those problems. Okay. So what can we do in data remediation? We can do these things. So we can remove outliers. So if you have a lot of outliers, in your data, sorry, if you have very few outliers, if the number of outliers is not many, you could go ahead and remove the outliers, okay? And the second thing you can do is imputation. So you can impute the value with the mean, median, or mode. Okay, so this goes for both missing values as well as outliers. In the case of missing values also, you could just remove the rows that contain the missing values. Imputation is, instead of removing the rows that have missing values, you could just take a mean. If you have a numerical column, you can just take the mean average of all the values that you have in that column and replace it in the missing value. You can also take the median of those values or mode and replace in that position. And you could also do the same thing for outliers. So instead of removing outliers, you could just replace them with the mean, median, or mode of that column. Okay. The third thing you can do is known as capping. So if you are having outliers, outliers are basically values that fall beyond the 1.5 IQR limit. And you can replace those observations below the lower limit with the value of the 5th percentile, and those that are above the upper limit with the value of the 95th percentile. So the 5th percentile is essentially Q1, and the 95th percentile is actually Q3. So what you could do is just replace the values which are outliers with, if they are below 1.5 IQR, you can replace them with Q1. If they are above 1.5 IQR, you can replace them with Q3. So that's what you can do in data remediation. Let's now see practically how you can implement some of these things. So let's talk about removing outliers. So here I have a code where I'm using this AutoMPG dataset. Once again, if you want to look at it, this is what the dataset looks like. It contains all this data, and I believe it has some approximately 400 rows. It contains data about different car models, their miles per gallon, cylinders, displacement, horsepower, weight, acceleration, model year, and origin. And here I have printed out the first 5 rows for you to see. And hopefully by now you are quite familiar with this function that reads a CSV file and then prints the first 5 values. Now let's define a function to find outliers. So first we just want to find outliers. We don't want to remove them yet. So how do we do that? So we are creating this function called find_outliers. And in this function, I am passing 2 things. One is my data frame, okay? And the second thing I'm passing is the column in my data frame from which I want to find the outliers. So I want to find the outliers from MPG. So I'm going to pass that, okay? So there are 2 things, the data frame and the column, as you can see here. Now what we will do is, first of all, we are going to find out Q1 and Q3. How to do that? So Q1 is basically your 25th percentile of quantile, and Q3 is your 75th quantile. To do that, you just have to pass, you just have to do DS and then the name of the column, which will be a string, and use the quantile function, which comes with pandas. So you just use dot quantile, pass which quantile you want, and here also quantile, pass which quantile you want, and you will get your values of Q1 and Q3. Once you have the values of Q1 and Q3, you can calculate IQR, which is also called interquartile range, which is Q3 minus Q1. We know this from the statistics that we have studied, that this is Q3 minus Q1. So it's just quart 3 minus quart 1. Now we have to decide what are outliers. So outliers are usually values that lie beyond quartile 1 minus 1.5 IQR. So basically, you will have a line like this. This will have your minimum value. This will be your quartile 1. This right here, this will be your median. Okay. This will be your quartile 3. And here you will have the maximum value. And we know that the IQR is basically this. This is IQR. So what you are trying to do is from quartile 1, you are subtracting 1.5 times IQR. So whatever is IQR, subtract 1.5 times the IQR, and maybe you get something here or here. So whatever point you get, let's say you get this point, okay, or you get this point. Now, whatever is beyond that point, okay, whatever is less than this, will all be considered outlier. They will all be considered outliers. And same thing for this is the low value. Then there's high value, which is quartile 3 plus 1.5 times IQR. Okay. So if suppose you get this point, then whatever is beyond this point, okay, greater than, is going to be an outlier. So basically, we found these limits of normal values, values which are not outliers. And those limits are this low value and high value. Now, from our data frame, we are going to locate using the dot lock function all the values that fall less than this low value, okay? And as well as you can see the pipe over here, pipe means or. So it is either less than the low value or it is greater than the high value. So all such values we are going to locate and then return the data frame. And here you can see I'm calling the function outliers with the data that I have, as well as MPG, which is the column from which I want to find the outliers. So you can see as a result of this, this is the output generated, and it contains one row, which is, I think, the row with ID 322, and it has an MPG of 46.6, which is an outlier. Which must be very high or very low compared to the average or the standard deviation. Okay, so you can see it over here. And yes, 46.6 must be really a very high miles per gallon for any kind of car. Okay, you can see its origin model year was in 80s. It is a Mazda GLC with 4 cylinders and this much horsepower. And this outlier could be anything. It could be a mistake by someone who did the data entry, okay? Or it's just an outlier and it's just a car that has an exceptionally high MPG. So this is how you can find outliers. Now let's talk about removing outliers, okay? So this was just finding the outliers. Let's see how you can remove the outliers. So here I have another function with which you can remove outliers. So this function is pretty much the same as we saw in the previous function. We are finding the quartile 1 and quartile 3. Then next we are finding the IQR, which is the interquartile range. Then we are finding the low and high values, which are quartile 1 minus 1.5 times IQR, and the high value is quartile 3 plus 1.5 times IQR. The only difference here is while locating it, we have used this symbol over here. Okay, so all the values which are within this, okay, all the values that are greater than the low value and that are less than the high value. So earlier we were talking about all values that were less than low value and all values that were greater than high value. Those were outliers. This time we are talking about all values that lie between these two. The reason for that is that I just want these values, others I do not want. So I'm locating all the values and placing them into this new data frame, which is the data frame I will return. And you can see I'm calling this function, remove outliers. And while calling that function, I'm passing my data frame along with the column from which I want the outliers to be removed. And I'm taking this data frame, I'm storing that into my new data. So this is my new data frame that I've created. And once it's done, I want to check if it actually worked or not. So to do that, I can again call my find outliers function. And this time, instead of passing the old data frame, I'm going to pass the new data frame, which I got after removing outliers, and pass the column name as MPG. And you can see there is the result is just names of different columns and nothing is there here because there is no outlier present anymore. It got removed. So this is how you can find and remove outliers You could also find and replace the missing values from your data um, by just finding such values and then replacing them in the same manner like we replaced outliers, like we removed outliers. So I hope you understood this, and I'll be back with the next video. Thank you for watching.